Today I'm going to show you how to power a 20-ton press using a jigsaw. If you're new to this channel, then make sure to hit that subscribe button. All main parts will be linked in the description, and let's get started. The shop press I'll be using is a 20-ton or 40,000 pound shop press. The reason why I came up with this idea is because when using this shop press, in order for the punch to travel all the way down, the hydraulic jack needs to be pumped about 70 times, which in some cases can be quite time consuming. So my solution is using a jigsaw, which can create a quick and powerful up and down movement to pump the press. I had this one laying around, but you can get one from Harbor Freight for just under 20 bucks. But the big question is the jigsaw powerful enough to get the press to smash metal? I mean, the press is definitely capable of doing that, but to find that out, we'll firstly have to find a way of connecting the jigsaw's output shaft onto the press. To do that, I thought of using the bar that the press already comes with and give it a tack weld. Next, we'll grab a bottle jack and steal a specific part from it. This part will allow the jigsaw to stay stationary while it pushes and pulls the bar up and down. But before connecting this part onto the jigsaw, we'll need to remove some parts that are in the way. My plan is to connect this yellow part onto the jigsaw shaft, but as you can see there are two unnecessary parts, so we'll go ahead and remove those. This aluminum blade bracket is also in the way, so I'll remove it as well. I'll use a nut to create a joint between the jigsaw shaft and the pin, and reduce friction by drilling out the threads to provide a smooth surface between the pin and the nut. Before welding the joint, I fitted some washers onto the pin to fill the gaps. Now that this part is properly attached, we can move on to cutting the extra steel bar so that the jigsaw can be mounted. I will have to test out this contraption before mounting it, so here's a 12-volt battery and I'll hook it up to the jigsaw. Well, it works. If you think this is slow, then I fully agree with you, because this jigsaw is designed to run at 10 times this voltage, but it wouldn't be safe to do that in this case, would it? Which is why we can now move on to mounting it. For that, I decided to weld together 4 L brackets to get some extra strength. Now that the jigsaw is mounted, we can go ahead and test it out. This time, instead of using 12 volts, we'll use 24 volts. With 24 volts, it kind of sounds like a train. Let me know in the comments what you think it sounds like. When all sounds well, there is only one minor problem. When applying a load to the press, the Jigsaw starts rocking back and forth. Thus, the Jigsaw does not transfer all its power to the press. My solution is to build a support cage around the Jigsaw, which should prevent any rocking. I'll be using some rebar to build the support cage. Now that the support cage is complete, let's see if the Jigsaw will be rocking when loading the press with a piece of metal. This time, we'll use 120 volts since the Jigsaw is properly secured to the press. As you can see, it barely vibrates and has way more power than before. But wouldn't it be nice to have the ability to control both the press's down movement and up movement with your fingertip? For that, I'll be using a joystick, which is great for precisely controlling electrical components. The joystick will be connected to a Arduino Nano microcontroller, which will control the positioning of two servos. One for controlling the speed of the Jigsaw, and another one for opening and closing the pressure release valve. If you're wondering how I will be using a servo to control the Jigsaw's speed, then here's my idea. The speed controller that I'll be using has a knob for controlling the speed. So in theory, if I connect the servo to the speed controller, I should be able to accurately control the speed of the Jigsaw. To do that, I 3D printed an adapter which will connect the servo onto the speed controller. Now that the adapter is on, it actually looks quite promising. So the next step would be to mount the servo onto the speed controller. For that, I'll use 4 long bolts and some nuts. Now that the speed controller assembly is complete, we can go ahead and give it a test. If you're wondering what code I wrote, then here it is. The main part of the code is where I tell the microcontroller to map a certain range of the joystick's movement onto the servo. In this test, I connected a angle grinder onto the speed controller, and let's just see how well it will control the speed. I'd say that's a win. Next, I 3D printed an adapter which will connect the second servo onto the pressure release valve. I'll be using some long bolts and nuts just like we did with the speed controller, and I'll weld it on. Alright, it's done. So let's give it a test. It seems to be working fine, so now I'll go ahead and 3D print an enclosure to house all the components. Now that the housing is printed, let me talk about its features. This housing comes with 4 holes, 2 for power input and output, 1 for a power switch, and finally the biggest hole is designed to hold in place the joystick, which didn't fit in the first time, so I had to redesign and 3D print it again. This design also features some built-in brackets to hold the joystick in place. Before packing all the electronics into the housing, I'll salvage a power supply from a power adapter instead of using the battery we used for testing. Now that all the components are ready, we can now proceed with connecting all the electronics together and packing it all in. And it's done. So now we can go ahead and mount it onto the press's frame. To mount it, I chose to use self-tapping screws. For the final part, we'll close up the enclosure using some coarse threaded screws and connect the cables onto the servo and jigsaw. Now that the project is complete, it's time to give it a test. For the first test, I will attempt to press a staple and 2 screws into a 2x4. The staple is 1 inch long. Well, that left a nice dent in the wood. Next up is the screw. It's a 1.5 inch screw, and let's see if the press can drive it down without bending like the staple. Pretty satisfying, no? Well, let's do another one just for the heck of it. These screws are nice and flush, not a bad alternative if you don't have a screwdriver. If you're wondering how fast it runs now versus before the modification, then before it was modified, it took 1 minute and 20 seconds to pump from top to bottom, and now it only takes 30 seconds, which is 37.5% faster. Next up is a 1x1 inch steel square tube. Wow, I didn't expect the Jigsaw to have so much power. Anyway, I saved the best for last, which is my old watch that stopped working for unknown reasons. If you like this video, then make sure to subscribe and hit the notification bell in order not to miss any of my new videos.